Assalamualaikum and good day. In previous video, we already looked at some terminology on solidification of pure metal and alloy. In this video, we are going to look at solidification itself of pure and alloys, and then we are going to look a little bit on cooling curve. When we talk about solidification, it means that it involves in liquid solid phase transformation. So it will start from liquid phase and then it will cool down until it become or it form solid phase. For metal, we can take example as casting process where the metal is heat up to a certain temperature until it melted, and then you can place the impurities in that metal. After that, you pour it down into the mold and let it cool down to solidify it. The solidification process differs depending on whether it is pure element or an alloy. This slide is to show you the process of solidification of pure metal and alloys. As you can see here, it starts at high temperature where the metal is melted until its liquid state. For pure metal, we don't add any impurities. For alloy, we can add impurities to make a special characteristic. And then this is the cooling down process. When the temperature is dropping, the nucleus will start to form in the liquid state of that metal. This stage we call it as nucleation of crystal stage. This is where the solidification start to happen. This stage happens when the temperature drops below the melting temperature of the metal. When we keep on cool it down, the nucleus will grow bigger and bigger. This stage we call it as crystal growth stage. As you can see here, the solid will take more and more area in the liquid. Lastly, when we cool it down further, the crystal will grow together and form grain boundaries. As you can see here, there is no more liquid. All of this just a solid, and then there are grain boundaries here. There is the solidification process of pure metal and alloys. Now we are going to move into cooling curve. We will see the difference between cooling curve of pure metal and cooling curve of alloys. The cooling curve is used to determine phase transition temperature. What it is mean is we want to know at what temperature the liquid phase turn into liquid plus solid phase, where the solid start to produce, and then we also want to know at what temperature the liquid plus solid phase change into solid phase only. Cooling curve will show you the temperature and time data. It is used to produce a graph known as phase diagram, which shows the relationship among temperature, composition, and phases present in alloy. What we have over here is the cooling curve for pure metal. As you can see, it starts at A, where the metal is in liquid state, and then when the temperature drops until the freezing temperature, it will form a constant temperature over the time. This is where the solidification happens. The solidification happens at B, and the solidification ends at C. For pure metal, the freezing or melting temperature is only 1 because only one metal available. The solidification temperature will be constant at melting, or we call it freezing temperature. Then what happened over here? What we have over here is when, for example, we pour the liquid metal into the casting mold. So the heat from the liquid metal will be transferred into the surface of mold body to make it drop a little bit more below the freezing temperature of the metal, and then it go upward again and then constantly solidify. After the solidification end, the solid state or solid phase metal will cool down until the room temperature. Theoretically, this is the cooling curve of pure metal. Over here, we can see a pure metal solidify at constant temperature. Over here, solidify equal to its freezing point, which is the same as its melting point. And then we have cooling curve of alloys. Most alloys freeze over the temperature range rather than at single temperature. You can see the solidification process occurs here. There are a bit of slope occurs when solidification of alloy, not like pure metal where the constant temperature occurs at solidification. This is because for alloys, we have two or more components. For example, if we have nickel and copper, the nickel and copper will have different melting, or we call it freezing temperature. So the solidification will happen with a little bit over a temperature range. This temperature range depending on the melting or freezing temperature of nickel and also the melting or freezing temperature of copper. The cooling curve at B is showing for 50% copper and 50% nickel. So the solidification at 50% copper nickel occurs at this temperature. For further understanding, we will keep on looking about this on the phase diagram later on. Now we are going to look at development of phase diagram from the cooling curve that we looked at before. The phase diagram is produced from series of cooling curve at different metal composition, and then point of change of slope of cooling curve are noted and phase diagram is constructed. More the number of cooling curve, more accurate is phase diagram. We start with the pure copper cooling curve. For pure copper, we plot the temperature versus time. For the pure copper, we get a constant solidification temperature because it is a pure metal. We are using pure copper. After that, we add on 20% of nickel into that pure copper. So it will become 20% of nickel and 80% of copper. Over here we can see it produces a slope for solidification process. Start with L1 temperature and stop at S1 temperature. After that we use 50% of nickel. It means we have 15% of copper in that solution. We get L2 and S2 for the solidification temperature. After that, also the same, we use 80% of nickel and the content of copper 20%. And lastly, we use pure nickel. So for pure nickel, as in the pure metal state, we get a constant solidification temperature. And then we plot this temperature over here. So we get at 100% copper, we have this temperature. And then at 20%, we have L1 and S1. At 50%, we have L2 and S2 taken from the cooling curve. It keeps on going for 80% and until 100% of nickel. Over here, we take this temperature and plot it in the phase diagram. After that, we continue the dots and we will get the phase diagram for copper nickel alloy. This phase diagram, we call it as binary isomorphous phase diagram. In the next video, we will look at the binary phase diagram. That's all a little bit on cooling curve of pure metal and alloy. I hope you can understand the content. If not, you can contact me. Till we meet again. Thank you.